Mark Rosengarten. Welcome to
Ask Rosengarten.
Good afternoon, ladies and gentlemen. Welcome to Ask Rosengarten, where I, Rosengarten, answer the questions that you ask. I have a question today from Victor Doan. He says, can you do a video about determining limiting reagents? Thank you. I've actually gotten a lot of requests for limiting reagent videos over the last few months. It's not part of what I teach, but it's basically an extension of what I teach. It's just basic stoichiometry. Now, your typical stoichiometry problem might read something like this. If you have 80.0 grams of this reactant, how many grams of reactant will it take to completely react with it? After all, it's a 2-to-6 ratio of alcohol to oxygen. 2-to-6. That's really a 1-to-3 ratio when it comes right down to it. So if I had 2 moles of alcohol and 7 moles of oxygen, then the oxygen would be in excess, which means that the ethanol would be the limiting reactant. If I only had 5 moles of O2 for 2 moles of alcohol, then the oxygen would be the limiting reactant because it doesn't have enough to make the proper stoichiometric ratio. Now, for the example that we have here, if we had 80.0 grams of ethanol and 50.0 grams of oxygen, and we want to figure out which one is the limiting reactant, what we have to do is convert these grams into moles. Again, with stoichiometry, it all comes down to moles. So if you want to do anything involving stoichiometry, whether you want to find out how many grams of product, theoretical yield of product from a given amount of reactant, or if you want to do a limiting or excess reactant kind of problem, it all comes down to stoichiometry. It all comes down to converting grams to moles. Now, the way you convert grams to moles is you divide by the gram formula mass of that compound. So there's 12 times 2 is 24, 29, 30, 46.0. For the oxygen, it's, well, there's 2 oxygens at 16 apiece. That's 32.0 grams per mole, so that the grams cancel rather, when you divide them. Okay, so now they're out in the open where we can really get our hands on it. It's a 1.74 moles to 1.56 mole ratio. Well, it's already going to become apparent. You see, because it's a 2-to-6 or a 1-to-3 ratio, right? Because 2-to-6 simplifies to 1-to-3. So we can already start to see that if this is a 1-to-3 ratio, oxygen should be 3 times as much as the ethanol if it's going to be stoichiometrically correct. That means the oxygen is going to be the limiting reactant. If we take a look at this ratio, it's a 1-to-3 ratio. So if we take the moles of C2H5 and multiply it by 3, if the ratio holds true, then to perfectly react this, to use up all reactants, would require 5.22 moles of oxygen. Well, we don't have 5.22 moles of oxygen. We only have 1.56 moles of oxygen. This is the limiting reactant. And what's going to happen is, as this reaction proceeds, the oxygen will get used up first and leave behind an excess of ethanol. How much of an excess of ethanol? Well, that's also pretty easy to figure out. You see, because it's a 1-to-3 ratio of alcohol to oxygen, which means that when you use up the oxygen, you should have used up 1/3 as many moles of the ethanol. So 1.56 divided by 3, because the ratio is a 1-to-3 ratio, means that only 0.52 moles of ethanol will be used up by the reaction. Now, we have 1.74 moles to work with, but we're only going to use up 0.52 moles of it. That gives you your 1-to-3 ratio. So how much ethanol is going to be left over when you're all done? Well, let's subtract it. We had this much to start with. We have this many to end with. 1.22 moles. You want to find out how many grams of ethanol is left over when you're all done? Easy. Multiply by the formula mass. 46.0 grams per mole. And that means of our original 80.0 grams, we would have 56.1 grams remaining after all the oxygen has been used up. So just to recap what I did here, I'm making use of the ratio between the reactants. It's a 2:6, or simplified 1:3 ratio. So if I want to find out which one is the limiting reactant, I have to convert both of them into moles and then use that ratio to compare. Theoretically, it should take 3 times as much oxygen as it does ethanol. We're talking in terms of moles because this is a mole ratio. So the oxygen is the limiting reactant. Since the ratio is 1:3, it'll take only 1/3 as much ethanol as oxygen to make this reaction work. So theoretically, I should only need 0.52 moles of our ethanol to react completely with all the oxygen we have available to make this reaction work. Once all the oxygen has been used up, that leaves behind 1.22 moles of our excess reactant. And then to convert that back into grams, multiply by formula mass, and that tells you how many grams of your excess reactant is left over when all is said and done. If you can work with a proportion, if you can work with ratios, the trick behind this is everything needs to be converted into moles. And once you do that, it's really not that big a deal. Again, it's just stoichiometry in action. It's interesting that I've been getting such a large number of questions relating to solving stoichiometry problems. Go back, take a look at my videos. If you have any additional questions, if you want additional examples, please email me. Get in touch with me and let me know how I can help you. Just email me at askrosengarten@gmail.com and I'll make sure I get to your question. So, what are you waiting for?
Ask Rosengarten!